Please state your name after the tone, then press pound. You will now be placed into conference.
Yeah, maybe. Okay, so let me say something. So we are talking about some mobile for the uplink. Okay. And that mobile is given, let's say, 12 subcarriers. Okay, a dozen subcarriers. That's the minimum allocation. So if you want to send out your modulation symbol, then we will send 12 symbols on one subcarrier during one symbol time. Another set of 12 modulation symbols on the same subcarrier in another symbol time.
Right.
Okay, so now let's pick one specific symbol time, OFDM symbol time, which is 66 microseconds. Okay. So the first thing that we do is we take those modulation symbols and do the DFT. Now the nice thing about DFT is if you give the DFT 100 inputs, it will give you 100 outputs, same number. So whatever numbers of modulation symbols you give to the DFT, it will give you the same number of output symbols. Okay, so if you give 12 modulation symbols, it will give you some 12 complex numbers. Okay. Okay. So now you have transformed your original modulation symbol into some complex numbers. Okay. And that transformation is based on the DFT formula. Okay. So now you take one complex number and put that on one subcarrier. Take second complex number, put that on second subcarrier. So now contrast that with regular OFDMA processing. In regular OFDMA processing, one modulation symbol was placed on one subcarrier. Another modulation symbol was placed on second subcarrier. But now, instead of placing the modulation symbol, we are placing so-called complex number, which is transformed modulation symbol onto the subcarrier. So when you do the IFFT in SC-FDMA and you observe the transmitted signal coming out, then you have to take basically that is a digital signal. So you are observing the signal at distinct time instants. If you pick any time instant, at that time instant, the amplitude will be affected by one modulation symbol. If you pick another time instant, that will be influenced by just one modulation symbol. And exactly which modulation symbol will affect the sample time, that will just depend on how many subcarriers we have allocated to the user and so on. But the basic idea is that the user is still able to send the same amount of information. So whatever OFDMA can do, the same data rate will be there. The only thing is we have now transformed transmitted signal. It's not the IFFT original OFDMA signal. It is now SC-FDMA signal. And the main difference between the two is we have now lower peak-to-rate variation. So we are still sending the same number of modulation symbols. So if I say that I have one OFDM symbol and I have given 1 dozen subcarriers, the user is still sending only 12 modulation symbols because one subcarrier, right, effectively carries one modulation symbol. So that rule doesn't change. So as a mobile device, you will still be sending the same amount of information. The only thing is the structure of the transmitted signal is now different. Does that make sense?
I don't know.
Okay. So what is your confusion? Okay. So your confusion is that we give n modulation symbols and only one symbol is coming out. Is that your confusion?
Right.
Oh, no. Okay. So let me clarify. So if n modulation symbols go into the DFT block. Okay, let's say not DFT block because we have to do DFT multiple times. Okay, maybe I will give you another example. Okay, let's say I have 24 subcarriers. 24. You see, unfortunately, I cannot touch the screen. I cannot use the journal tab because the survey is up. Okay. So hopefully you can still figure out what I'm saying. So we have 24 subcarriers allocated to that mobile device or up now. And now let's keep things very simple. You have 24 times 2, 48 modulation symbols. Okay. Assume that you have 48 modulation symbols. So what you will do is you will put 24 modulation symbols, okay, and send those during the first OFDM symbol, because during the first OFDM symbol you will have the capability of using 24 subcarriers, and total number of modulation symbols you will send out is still 24 because you have 24 subcarriers. Then you will use the same 24 subcarriers in second OFDM symbol. So again 24 subcarriers, 24 total modulation symbols can be sent out. So you occupied in this example 2 OFDM symbols to send out a total of 48 modulation symbols. So 24 symbols in one symbol time instant, another 24 symbols in second OFDMA symbol period. Are you okay so far?
Right.
Okay, good. Now let's pick the first OFDM symbol. We are saying that within the OFDM symbol, we have 24 subcarriers. That should give us capability of sending 24 modulation symbols, because our rule is one subcarrier should give you the capability of sending one symbol out, right? Okay. Now we give those modulation symbols, let's say 24 modulation symbols, to DFT. Now we will do 24 point DFT, meaning 24 symbols, modulation symbols will be going into the DFT and 24 symbols will be coming out of the DFT. Does that make sense?
Yeah.
Okay. So now the DFT gives you some sort of 24 complex numbers. Okay, 24 complex numbers. And each complex number is some sort of transformation of those modulation symbols, okay, which were at the input of the DFT. So are you okay so far? 24 complex numbers out of DFT?
Right.
Okay. So now we have 24 complex numbers. One complex number will now be placed on one subcarrier F1. Second complex number from DFT goes to F2, that is subcarrier number 2. Third complex number goes to third subcarrier, and so on. Okay. Now that goes into this big IFST. Now, depending on how much spectrum we have, right? Let's say we have 10 megahertz spectrum bandwidth. So then we would have so-called 1024 point IFST. Okay, it means that we would have to take samples, okay, of the signal which will be at the output of the IFST. So we will have OFDMA, in this case SC-FDMA symbol times, let's say 66 microseconds. So inside 66 microseconds, there would be 1024 sample time instance. So it doesn't matter how many subcarriers you have. You will have those many sample time instances because you need to send this signal over the air, and that signal would have 1024 sample times, different samples at different times. Now, if you look at the formula for IFST, that formula will give you the total number of 1024 values, because it is a 1024 point IFST. So you have only 24 modulation symbols going into the, 24 complex numbers going into the IFST block. But that IFST block, because of 10 megahertz bandwidth, is 1024 point long. Okay? So now you have many samples. So if you pick any sample time instance, it will be influenced by one of those 24 modulation symbols. If you pick, let's say sample time number 900 out of 1024. It will be influenced by one of those complex, one of those modulation symbols. Then you pick the last one, 1024, sample number 1024. It will again be influenced by one modulation symbol. So rather than the output of the IFFT, right, at a given time instant, rather than that amplitude being influenced by all modulation symbols, now at that time instant, the amplitude is a function of one modulation symbol. Okay, because the way the DFT and IFFT operations will sort of cancel out with each other effectively. So the end result is that still in one OFDMA symbol, even though you have those 1024 sample times, you are still sending the information about 24 modulation symbols in the form of 24 complex numbers. So effectively, you are still sending the same amount of information, but the way you are sending that information is different. So you still have information about all 24 modulation symbols present at the output of IFFT. So it's not that, we have n modulation symbols going into DFT, but the IFFT only gives you one symbol. You still have the content. The content still is 24 modulation symbols, although represented differently by the structure of the transparent signal.
Okay, so how do you come up with the 10,024 sample time?
1024. That is just based on the bandwidth. So if you have 20 megahertz bandwidth, you will always have 2048 different samples of your signal. If you have 5 megahertz bandwidth, the 512.f point IFFT will give you a total of 412 sample times. So that is just based on the amount of bandwidth that you have.
Okay.
Okay.
All right, thanks.
Okay. And whichever subcarriers you do not have, for the input to the IFFT, you just put 0 on that. So your complex number will be placed on the subcarriers that have been allocated to you. If a subcarrier has not been allocated to you, you just put 0 on that. Okay. So basically, there is no energy on that subcarrier. Okay. Thanks for the question. Any other question? Any follow-up question or anything at all?
I just have one question.
Okay.
One time when you talk about the uplink,
Okay.
link budget, you said I didn't quite get it. You said the mobile would keep at the maximum power? Does that mean would it burn the battery life?
Oh, okay. So what I'm saying is the following. When you want to calculate the link budget, meaning the dB path loss, that we
Okay, so you are assuming the back the power.
Yeah, maximum battery power, yes.
Okay.
Yeah, maximum UE power.
Okay.
Okay. Yeah, so link budget has one of the inputs, which is this maximum UE power. Okay. So if you have lower peak to average power ratio, then you have effectively more power available for data traffic.
That's true, yes.
Right? Okay.
Thank you very much.
A smaller back-off value. That is the idea. Okay. Any other question?
Question for the survey. My computer hangs after I hit the return.
And